Hello. Now we are going to look at how to find the coefficients of functions. So when we're looking for the coefficients of functions, what we're trying to do is complete the description of a set to describe the function fully. So if we look at the function f of x here, we have a complete description of what f of x is. What I mean by that is we know how to go from the input to the output of the function. So if I input a number in f of x, I times that input number by 4 and I subtract 2 from it, and that gives me the output or the y output of the function. So that is how we describe all of the points that would be in the group f of x. You times the x number, the input number, by 4, you subtract 2 from it, and it gives you the y number, the output number of the function. And if the relationship between x and y is that you times the x number by 4 and subtract 2 from it, and that gives you your y value, then that point is on that line. If we look at g of x here, we don't know the relationship between the input and the output for g of x. We can see that it's a straight line because it doesn't have any x squareds or square roots or anything in it on the x's. But we don't know what we would have to multiply x by and add or subtract on in order to get the relationship between the input and the output. So when we find the coefficients, what we're doing is finding the description of the relationship between the input and the output. So let's look at this in practice. For if we know the description and we want to see if a point meets that description. So if we have the point 2, 7, is that point on the line f of x? If we drew it, would it be a point on the line f of x? Or is it a member of the group f of x? Well, if it's a member of the group f of x, that means that x is 2 should give an output of y is 7 using this relationship. So does it? If we have f of 2, is that going to be equal to 7? Well, 4 by 2 minus 2, is that equal to 7? So 4 by 2 is 8, minus 2, 7, 6 is equal to 7. Well, 6 isn't equal to 7. So that means that this point does not have the right relationship between the input and the output. So that means that, if I put that in a different color, that 2, 7 is not a member of the group f of x. Not an element, if we use set notation, because it doesn't meet the relationship between the input and the output, between the x and the y. Now, this is the same information given in function notation. Is f of 3 equal to 10? When we input 3 into the function, do we get 10 as the output of the function, or is 310 an element of the set? So f of 3 would be equal to 4 times 3 minus 2, is that equal to 10? So we end up with 12 minus 2, and we end up with 10 is equal to 10. And that's true, 10 is equal to 10. So that means that when we input x is 3, we get out y is 10. So that tells us that the point 310 is an element of the set f of x. It's a member of this group. This x leads to this y, so it meets the description. And that's what we need to get in general. When we have a function, we have a description of the relationship between x and y. So if a point is on the line, it solves the equation of that line. It meets the description of that line. If we had a really simple straight line equation like y is equal to x, would the point 6, 3 be on that line? Well, no, it wouldn't, because all of the points on this line have the same x and y value. X should be equal to y, and 6 is not equal to 3. So that point doesn't meet that description. Now, if we look at that from the other direction, if we know points that are on a line that meet the description of a function, can we work backwards from that to figure out what the description of the function must be? When we find coefficients, that's what we're doing. So if we know g of x is a straight line, it's in the form y equals mx plus c. So we know we've got a straight line, and we know these 2 points are on the line. So minus 2 minus 5 is an element of g of x, so that's a point on the line. When x is minus 2, y should be minus 5. and g of 1 is equal to 4. That means if we input x is 1, we should output y is 4. So if I get a question like this, I'm going to say, well, if I know that those two things are supposed to be true, what I'm going to do is put them into the description of g of x that I've got and see if I can make progress from there. So if we just go with what we've been given, can we make progress once we've done that? So we sub into our equation g of minus 2. When x is minus 2, y should be minus 5. So a times minus 2, x is minus 2, plus 5, plus b, should be equal to minus 5. So I end up with one of the things I know must be true is that minus 2 plus b should be equal to minus 5. Now I have an equation with two unknowns in it, so I think I need to use simultaneous equations. But I'm going to get my second piece of information I was given and see if that works out. So I end up with g of 1 should be equal to 4. So a times 1 plus b should be equal to 4. So I end up with a plus b is equal to 4. Well, yep, I ended up with two equations and two unknowns. So I can solve them simultaneously. Now I could do that by substitution or subtraction. In this case, I'm going to do it by subtraction because I have, if I subtract this equation away from this equation, I'll end up with an equation that only has a in it. So that's what I'm looking for simultaneous equations by subtraction. I'm going to write down my two equations and say, well, if both of these things are true, could I subtract one from the other so that I end up with an equation that only has one letter in it? Because if this is equal to this, and this is equal to this, and if I add this side to this side, and this side to this side, the equation still must be true. And can I add them together so that I end up with only one letter? That would be very useful. So I'm going to take equation 2, and I'm going to subtract away equation 1. I'm doing that because I can see that it will get rid of the b's and also leave me with positive coefficient for a. So I'm going to do that now. When I add these two equations together now, because I've subtracted equation 1, I've multiplied it by minus 1 here to keep track of what I'm doing, I end up with a plus 2a is 3a, b minus b is 0b, so I don't bother writing that down, and 4 plus 5 is 9. So now by adding those two equations together carefully, I have ended up with an equation with only one letter in it, and that's now going to let me solve to find my value for a. I can go back and find my value for b. So when I solve, I find that a should be equal to 3, and then I can go back to either of my original equations. Both of these should work, but this one's easier, so that's why I picked it. It has less complicated coefficients. So a plus b should be equal to 4. I now know a is equal to 3, so I can rearrange that equation to find b is 1. So going back to what I was looking for, I now know the description of g of x should be 3x plus 1. And that describes all of the points on g of x. I can fact check that very quickly. If I take g of minus 2, I'd have 3 by minus 2 is minus 6, plus 1 is minus 5. So I get the point that I was expecting, and when x is 1, y is 4, 3 by 1 is 3, plus 1 is 4. So the points that I had work for the equation I got. It's a very quick check to see that we did everything right. Now we can also do this for quadratic equations. We have a power of x squared here, and we have an x, then we have a constant. We can find the full description of h of x in the same way, because we know that if minus 2, 6 is on h of x, and when x is minus 2, y is 6, and when h of 4 is 0, we know that when x is 4, y is 0. If I know that, I know that these 2 points must solve this equation. So if I sub in x is minus 2, I must get an output, a y value of 6. If I sub in x is 4, I must get an output of 0. So even if I'm not sure where to go after that, I'm going to sub that information in and see what I have after that. When I've subbed in my values, I get 4a plus c is equal to 2 and 16a plus c is equal to 8. So again, two equations, two unknowns. I can do simultaneous equations, and again I'm going to do simultaneous equations by subtraction. I could also do substitution. So if I look at my two equations, I want to add these together so that I end up with one of my letters going to 0. Well, I could multiply this equation by -4 and I'd end up with minus 16a and plus 16a, and that would sum the a's to 0. But it's easier just to multiply this equation by -1, and then I'd be able to add them together and get the c's to sum to 0. So that's what I'm going to do now. When I subtract them, I end up with a is equal to 1/2. So now I can go back to either of my equations, equation 2 or equation 1, and sub in. I'm going to do equation 1 because it has smaller coefficients. I'm less likely to make a mistake. I now know a is supposed to be 1/2. So sub in 1/2. And I end up with 2 plus c is equal to 2. And subtract from both sides. I end up with c is 0. So I end up with c is 0 as my answer. So I end up with h of x is going to be equal to 1/2 x squared minus 2x plus 0. I don't need to write in the plus 0, but I will here for completeness as a final answer. So that's the description of all of the points on h of x. So hence find the y-intercept of h of x. Well, the y-intercept is where we cross the y-axis. And what's true of every point on the y-axis? We have all of our points that would be on the up and down the y-axis. The x-coordinate of those points has to be 0. So when I'm asked about the y-intercept, I'm being asked about x being equal to 0, because that's what's true for every point on the y-axis. So if I know that, I'm just now being asked for what is h of 0, what happens when x is 0. So h of 0 is going to be 1/2 on 0 squared minus 2 on 0, plus 0 if we like, and we just end up with 0. So that tells us that the y-intercept happens at y is 0, or the point 0, 0. The origin is on our line. So that's how we can find the full description of a function when we are finding its coefficients. And that is what we need for now.